I hope you all are good and enjoying my video lessons. Today, the topic what I'm going to discuss with you, that is binomial expansion for ACE level. As the term binomial mean two. Binomial mean two terms. Bi mean two and nomial mean terms. So the kind of expression in which we have to expand the two terms is called binomial expansion. uh, like we know, we are all well familiar about this, that any number power 0 is what? A plus b uh, power 0. That is, we know that this is 1. And if we have a plus b power 1, so it will be expanded as 1a plus 1b, because power is going to multiply with it. So if it is a plus b power 2, then it will be 1a square plus 2ab plus 1b square. And if it is a plus b power 3, we know this identity. You can multiply even the two results up above expression, like a plus b power 1 and a plus b power 2. If you multiply these two, we can get a plus b power 3. Or you, if you have remembered this, it will be 1a cube plus 3a2b plus 3ab2 plus 1b cube. And similarly, a plus b power 4 will be what it will be. You can keep multiplying 2 times, even a plus b whole square 2 times with itself. You will get 1a4 plus 4a3b plus 6a2b2 plus 4ab3 and plus 1b4. Here you can see, guys, we have a pattern of triangle here. Triangle, it is going to increase and so on. So it's not a difficult to find a plus b any with power any number, it can be 5, 6, but it will take little time, as we are going to increase the power of the terms one by one. If you're proceeding this is a plus b power 6, then we can expand it, and that a plus b 3 will multiply itself 2 times, we will get a plus b power 6, but it will take a long time to get the calculation. Here, if you will make a critical analysis of the in this triangle results, so then you can observe that first, in we have, whenever we have the power 0, that is 1, we have when power is 1, how many terms we have? 2 terms, 1 terms and 2 terms results. If power is 2, here is this 2, then we have how many terms in expansion? 3 terms. If power is 3, we have 4 terms. You can see, I'm going to underline it for you. If you have power 4, we have in the result, we have how many? 5 terms. So it means whatever is the power of the 2 terms, the result will, in resulting, we have always one more than the power terms, right? Any a plus b, if someone asks you what will be the number of terms in the expansion of a plus b power 10, so you can say the number of terms in the result will be 11, one more than the power, right? One thing is this, how many terms should be in the answer. And second thing, we need to be very careful about the coefficients, the number beside the variables a and b. right? uh, Here we can see always the first term is like here, a plus b. If you talk about, I'm taking the final one, a plus b power 4, you can see the first term is a4, right? And the power of the a is decreasing 1 by 1, while the power of b is increasing 1. You can see a power 4 mean, like, I'm going to write here, that is, I wrote 1a4. If I put b0, it doesn't affect because it is 1. Any number power 0 is 1. Plus, what it was, 4. Next one, a cube b. B mean b1. 6a2 b2 plus 4a1 b3 plus 1 a0 b4. You can see here in this expansion, every terms, the power of a is decreased by 1, while the power of b is increasing by 1, till we get the final power, right? One point. And second point, all the terms have a total index of 4. Yani all the terms, total index mean 4, mean if you add, if you can add the power of a and power of b, it is 4 plus 0 is what? It is 4. 3 plus 1 is 4. 2 plus 2 is 4. 1 plus 3 is 4, and 0 plus 4 is 4, right? But if you have here, like, above, from, I'm taking the values from the above triangle, if power 3, you can see it will be 1 a3 b0 plus 3 a2 b1 plus 3 a1 b2 plus 1 a0 b3. Again, the power of a is successively decreasing by 1, and the power of b is successively increasing by 1. So here, as the power of the binomial expansion is 3, so total sum of index will be 3. 3 plus 0 is 3, 2 plus 1 is 3, 1 plus 2 is 3, and similarly 0 plus 3 is 3, and so on. I hope you got these 2 points. 1 point, uh, then the number of terms in the expansion, binomial expansion. Binomial expansion means 2 terms expansion. Will always be 1 more than the power of the expansion, right? One point. And second point is that all the terms have a total index. Index means power, yeah, of n. And that means we can say, what is n? Power of the binomial expansion, right? So so far I hope is clear. Now furthermore, the final thing what is important here to know about the coefficients, where we put any 1 2 3, like sometime we put 3, sometime we put 4, sometime we put 6, you know. So 1, so this is more, these are called the coefficient, the number beside the variable a and b. So this is called the coefficient and n. In in order to get the coefficient, we can say now, guys, the coefficients in the above expansion, as we have this one in this triangle, we make it. The coefficient keeps its importance. So, how to write the coefficient? We can say, for in order to justify or explain the coefficients of the each expansion when n is 0, 1, 2, 3, like here you can see n was 0. I can say n was 0, here n was 1, here n was 2, 3 and 4, right? So whenever, if you when we talk about the coefficient of each binomial expansion, there was a mathematician, French mathematician, that his name was Blaise Pascal. He introduced a triangle that is called Pascal triangle. I'm going to explain you here. Pascal, sorry, Pascal triangle, and it is used to find the coefficients in the binomial expansion. It's very helpful to find the numbers. So suppose for the first, when n was 0, how many terms we had? We had one term, right? Like here you can see, I'm going to show you here. When it was 0, we had one term. It was 2, we had two terms. Just we are writing the coefficients. Let's see how. Blaise Pascal introduced a very accurate and easy pattern to justify these coefficients. When n is 1, so we have 1 here and 1 here, make a triangle. When n is 2, we had 1 here, and add these two, we get 2, and then in this pattern we will always write 1 from the corner of this boundary of the triangle. It will be 1, and rest will be in between. We can say the sum. You will see 1 as well. It will 1. Next it will be 1 here when n is 3. I can put the arrows to make clear with you. So what is 1 plus 2? That is 3. I will write 3 here. Then 2 plus 1, again we have 3, and then corner 1. When n is 4, 1 is corner value, and now 3, 1 plus 3, that is 4, 3 plus 3, that will be 6, again 4, and corner value is 1. So if it is n is 5, what it should be? Yes, corner value 1. You can get the coefficient in this way, in an easy way. It's 5, then 10, again 10, again 5, and corner value is 1. Now I will explain you here few questions from the book that is to be asked to use Pascal triangle. Use Pascal's triangle to find the expansion of like suppose we have 3x plus 2 power okay, say 4. As here, what is n? N is 4. So from a Pascal triangle, the coefficient of the expansion should be out of this pattern 1, 4, 6, when n is 4. So we can say here uh, the first term. Okay, now apply the expansion. as we know here, this is termed as A, this terms for B. So we have two term expansion with n4. So as per rule, power is 4. So now how many terms it should be? It should be 5 terms with the descending power of A. Like A will be 3x power 4 and 2 power 0 plus, now it will be 3x, leave the space for the coefficient here because we will write the coefficient later on as from the Pascal triangle. So 3x power, this is a will be as rule defined, its power must be successfully 1 decreased by 1, so it will be 3, and b power will increase successfully with 1, plus again the coefficient will be here 3x power 2, 2 power 2, plus again the coefficient will be here 3x power 1, 2 power 3, plus the coefficient will be here 3x power 0, 2 power 4. Okay, we got the 4. This is the final term. Now we need to think about the coefficient. As from the Pascal triangle, we know with the power when n is 4, the first is 1, and here it is 4, here it will be 6, then 4, then 1. This will be the coefficient. We can expand it to simplify our results, like it will be 3 power 4 mean 81 x 4, 2 power 0 mean 1. So here 3 power, you can use a calculator. 3 power 3 is 27 times 4 times 2, that is 216, 216 x power 3, plus here it will be 3 power 2 is 9, 9 and 4, 36 times 6, that again 216 x power 2, plus here we can get 8 times 3 times 4, we get 96 x plus 16. So this will be the final result of the expansion, this one. I hope it is clear to you. Okay students, uh, here's another question. Use Pascal triangle to expand this binomial expansion, like 1 minus 2x power 5. So Pascal triangle will help us, just to write the coefficients. So let's start. Coefficient. The first term here, a is 1 and b is what? Minus 2x. So 1 power 5 minus 2x power 0 plus, because if you have b negative, so must mention in each term, plus again the coefficient we need to write from the Pascal triangle. The successively a power will decrease from 5, it will be 4, and b power will successfully increase by 1 as the rule described before. So 1 power 3 here minus 2x power 2 plus the coefficient 1 power 2 minus 2x power 3 plus coefficient 1 power 1 minus 2x power 4 plus the coefficient 1 power 0 and minus 2x power 5, that is the highest power, final power, that is n, right? When you get n with b, stop. Here guys, from the coefficient as we have done in the Pascal triangle, here you can see when n was 5, the coefficient start from 1, then it was 5, then it was 10, then 10, then 5, then 1, right? As in the Pascal triangle we know this. So with the help of calculator, now rest of the expansion you can find 1 minus It will be 10x plus 40x square minus 80x3 plus 80x4 minus 32x power 5. This will be the final result for the expansion of this by using Pascal triangle, right? Now we will proceed for the part B. Part A has been done. Part B says find the coefficient of x3 in the expansion of 3 plus 5x times 1 minus 2x power 5. Already we have expanded with the part A, this 1 minus 2x power 5. The result should be multiplied with this. Let's see how to solve this part B. Okay, for part B, we have to find the coefficient of x3 with the expansion of this one times 1 minus 2x power 5. So let it be 3 plus 5x because power 1. And the result of this one from part A, we will write 1 minus 10x plus 40x square minus 80x3 plus 80x4 minus 32x5. Right? Now, see, if I multiply this 3 with minus 80x3, I can get coefficient of x3, right? And 5x with 40x4, it will be x3. And the rest of term, we have different power of x. So, we will write terms involving the coefficient of x3 are what will be 3 times 80, yani minus 240 x3 and plus 200 x3. So we can simplify it, minus 40 x3. So therefore we can say the coefficient of x3 in the expansion of, that was 3 plus 5x times 1 minus 2x power 5 is, what is here, minus 40. That is my final answer. I hope it is clear to everyone. Okay guys, now we are going to discuss about the binomial coefficients, because so far we have done the Pascal triangles. Pascal triangles we know can be used to expand a plus b power n. For any positive integer we can use Pascal triangles to get the coefficients. But if n is large enough, like if it is 100, if it is 50, if it is for 15, 10, 14, so it will take a long time to write all the rows in the triangle. You know, we need to make a big triangle depending on the number of n. Therefore, we need a more efficient method to find the coefficient expansion, and that efficient method is known as binomial coefficient method. Here I made a contrast between the Pascal triangle and the binomial coefficients, you can see. And for example, for the expansion of a plus b power 5, Pascal triangles, as we have done before, the coefficient will be like when n is 0, 1, n is 1, 2, 3, and we know this one. And for the coefficients, for binomial coefficients, when n is 0, n is what, n is here 5, so we can will start from 5c0. It's a combination rule, you can get easily on the calculator. That is in different calculator we have different options. Directly sometime we have ncr option in the calculator. We need to operate this one, right? uh, so with n is 1, so n 5c1 we can write in both ways, 5c0 like in vector, column vector, or in the combination rule 5c0. That mean this one. So finally, we get a binomial theorem for the expansion of a plus b power n, and is any positive integer, where here I can write where n is any positive integer, no matter how small or large it will be integer, then a plus b power n will be starting the coefficient nc0, nc1, nc2, like here nc0, nc1, nc2, so on, and finally until ncn, the final same number will turn out. And a is the first term, b is the second term. As already we know the rule, every times successively a will decrease or lose 1 from its power, and b will gain 1 in its power till the last term, right? So we will solve few questions to understand more about the binomial expansion. Okay, guys, take the example. A question is that find in ascending power of x the first four terms in the expansion of 1 plus x power 15. Here you know, here n is 15. So it's a bigger number, so we will not recommend you to go with the Pascal triangle to find the coefficients. And as we are interested to find the first four terms, so binomial expansion is the best approach, as you can see here. So use binomial expansion, and before we expand it, just write down what is the value of n is 15 here, as I wrote it here, n is 15, and a is what, a is 1, and b is what, x. So by applying that rule mentioned above, 1 plus x power 15 will be, we start from 15 c0, n is c0, 15 c0, a is 1 power 15, x power 0, plus then 15 c1, 1 power 14, and x power 1, 15 c2, 1 power. Successively you need to decrease the power of a1 with 1 at each term, and in each term you need to increase the power of b with 1. 1 2 3, and we have one term, we have two term, three term, and four term. 15 c3, 1 power 12, x power 3, and so on. We need to find, we don't need to expand it till the last term, because it has been mentioned in the question first four terms. So now with the help of calculator, you know 15 c0 will be 1, 1 power 15 is 1, 1 x power 0 is 1. Similarly 15 c1 is 15, and 1 power 14 14, and x will be like this. 15 c2, yeah, 15 c2, you can say, see, it will be 105. This is result from the calculator, 1 as it is, x power 2, and similarly 15 c3 will be 455 time 1 x power 3, and so on, right? So finally I will get the answer like this. This is with the ascending power of x. You can see this is the final answer. I hope it is clear to you. Okay, students, now I take another question. For the expansion of 2 plus k x whole power 5, the coefficient of x5 is 2 times the coefficient of x4. Given that k is a positive, find the value of k. Here, guys, we have been given a indicatedly that we need to be specified for the coefficient of x5 and coefficient x4. So no need to expand it till the last term. One method is true. You can expand it the whole and get the coefficient and compare with them. But directly, whenever you are given indicatedly the specific terms, so I can write for, this is, you can take as a note, the for the indicated terms, for the indicated term in the binomial expansion, we can have this formula. This is terms, tr plus 1 number of terms will be ncr a raised to power n minus r b raised to power r. We can apply this rule. As here we are interested for the coefficient x5, so r will be 5 and coefficient x4 r will be 4. So here I'm going to write, here n is what, 8, a is 2, b is what, kx. So for the terms, for the term in x5, first step, so at it will be n is 8 c 5, a is what, 2 raised to power, the difference of this 8 minus 5 is 3, and kx b power, yes, 5. With the help of calculator, once you solve it, we will get 448 k5x5. Also, for the term in x4, we can say 8c4, 2 power, the difference of these is 4, and b power, what comes, 4. With the help of calculator, once we solve it, we will get 1120 k4x4. Now go with the question. We have to, that it's given that we have given that coefficient of x5 is 2 times the coefficient of x4. So it means coefficient of x5 is 2 times the coefficient of x4. Coefficient of x4. So in order to equate them, as x5 is already twice this one, so if you need to multiply the coefficient of x4 with the 2 to justify the condition that they can be equal to each other, right? Hopefully this term, by how I write this one, is clear to you all. So here guys, I'm going to write the coefficient x5 here is what, we have 448 k5 is equal to 2 times 1120 k4, the coefficient of x4. So bring all k5 one side, k5 by k4 will be 2 times of 1120 over 448. So it will be k, and k will be, once you divide it with calculator, yeah, we can get k is 5. That is the value of k. I hope you got it. Okay guys, for this question, find the term independent of x in the expansion of this. Here we are interested to find a term independent of x. Again, it has been mentioned the term, so we can apply the specific rule. Independent of x mean the in which the coefficient of x, any x power is 0, right? In term independent of x, that doesn't depend on x. So the term that is independent of x is a term that when simplified, the expansion of this it doesn't involve x. So let's think on it, because the expansion of this, we need to stop where we can't write any more any expansion which involves x. So term independent of x mean that term which doesn't involve x. The term here, uh, the term that does not involve x. So expand it first. X plus 5 by x square power 9 is, can be, 9c0 x power 9 0 plus 9c1. X will be, because x is a and f5 by x square is b, 5 by x2 power 1 plus 9c2 x7, 5 by x2 power 2 is 4 and 7 3 plus 9c3 x power 6, 5 by x2 power 3 plus so on. I put it so on because originally I saw that it's x power 6 and it will be in denominator x power 6, that will be cancelled out and we don't have any x with it. So I can stop it, no need for me to expand it completely. So here I can write uh, the term independent of x is what? 9c3 x power 6, 5 by x2 power 3. We will see 9c3 is what? It will be 84 x6 and 5 power 3 will be 125 over x6. You can see it cancelled. So 84 times 125, 10500. So the term independent of x is this. That's my final answer for this question. I hope it is clear. But before we go for the another question, there is another method which will also use to find the indicated term. Let's see what is that method. Okay, in the second method, guys, uh, we can use the term independent of x as it has been given as the indicated term. So tr plus 1 is equal to ncr, already described with you, a raised to power n minus r, b power r. Here in the question, we are given n, that is 9, a we are given, that is x, b 5 over x square, r we don't know because we don't know which term will indicate us this thing, when which that coefficient is independent of x, mean it doesn't involve x. So here we apply this in this equation 1, the rule. This is the rule. So what comes? tr plus 1 is equal to 9cr. A is what? X raised to power 9 minus r. B is 5 over x2 power r. Okay, we need to write only one term of x instead of these two. So simplify a little. 9cr here, x power 9 minus r, 5 power r over x power 2r. By applying the indices rule here, we can shift these two terms of x in one. 9cr like this, 5 power r this, and will be x raised to power 9 minus r minus 2r. I applied the property of indices here. I'm going to write it in O level. You are well aware about it. Right. Now, suppose this is equation number 2 after writing all x in 1. So, for value of r, as we are interested to find a term independent of x, mean x raised to power 0, that means term independent of x. And here in equation 2 what we have, x raised to power 9 minus r minus 2r, that it is fine. So both sides we have the same basis. So 0 is equal to 9 minus, I can write 3r. So 3r will be 9. So r will be 3. So value of r will be 3. Now put the value of r in equation 2. We can put the value of r, that is 3, in equation 2. We get t3 plus 1, that is fourth term. It means 9c3 5 power 3 x power, it will be 9 minus 3 minus 3 times to 6. So 9c3 is what we will calculate it. It will be 84. It's 125 and it will be x power 0. So T4 will be 10500. In this way you will get the same answer. So even this method is very uh, commonly used among students. So it can be used for any coefficient term. Like if you want to get the coefficient of x5, so r will be here. You can say after x power, instead of 0 you write x power 5 is equal to this one and get the value. If it is coefficient of x4 and whatever to be asked, just you need to equate here at this stage of that terms to get the value of r. That will give you the answer. I hope it is too much clear to everyone. Okay, fine guys. Now I'm going to mention you the few homework. After making understand with this video, you can attempt, pure mathematics 1 by Sue Pemberton, right? This is the book title. And exercise number 6a and 6b. You are eligible to solve these two exercises based on binomial expansion. Okay, good luck, goodbye.